The topic, of course, is non-revenue water. The Danish Trade Council in Chicago and California-based Danish Water Technology Alliance, or the WTA, have teamed with AVK, Grundfos, Danfoss, and Camstrup, making their expertise in water distribution available to industry colleagues. The image here is taken from AVK's Omaha, Nebraska distribution center this past winter. The United States uses over 320 billion gallons per day of drinking water, including industrial demand. Nationwide, 15% greater average water loss is common. The Water Technology Alliance's goal is a close partnership between manufacturers and utilities to decrease non-revenue water loss to an average of 4% or less. Primarily, non-revenue water is public potable water that's produced by a public utility and then lost before it reaches the customer. Globally, the next frontier for public water supply systems is to target the reduction of non-revenue water loss. Leak detection is the key focus in the USA. The week of February 15th, for example, in a one-day period, the city of Tulsa, Oklahoma was trying to repair 143 water leaks due to temperature changes. Nature's water cycle seems simple enough. Condensation creates rain, which replenishes surface water levels. Runoff from excess surface water then has a time of travel that varies on soil permeability and eventually becomes groundwater. Humans have harnessed the water cycle and used both surface water and groundwater to create public water supply. Surface water being a source such as a river or a lake, groundwater being a source such as a well that taps into an underground river or aquifer. Unconfined aquifers have open upper inlets exposed to the atmosphere, and water seeps from the ground surface directly into the aquifer. Confined aquifers are deeper under the ground, capped off by layers of clay and impermeable rock that limit groundwater seepage into or out of the aquifer. Soil permeability determines the time of travel for rainwater to reach the aquifers. This is important in areas when pesticides or chemicals run off into fields or industrial sites that can run off into streams or rivers. For example, the famous Hot Springs National Park, the spring water there starts out as rainfall on the nearby mountains, and it takes 4,400 years to travel just 6,000 feet and reemerge in one of the 40 springs. However, if you go just 780 miles north into Minnesota, the story is much different. In Minnesota, watersheds are established in critical regions to determine the time of travel for rainwater to reach the aquifers, and they have 81 major watersheds on a 10-year cycle to protect their wellheads. For example, Rock River, Minnesota has 1,329 feedlots. Here, superficial aquifers recharge in just a few hours or a maximum of up to a week, and buried aquifers recharge within days up to a couple decades. 74% of the US's water is sourced from surface water, and the remaining 26% comes from groundwater. Water quality, economic growth, industrial expansion, and budgetary costs are worldwide issues. Non-revenue water loss is becoming an increasing focus. The AWWA and National Rural Water frequently report on source water issues in the news. In this one example, Haverhill, Massachusetts is being urged to protect the city's water supply and buy an additional 29 acres and declare it conservation land. Some of the city council members are balking as they feel they were previously forced to buy another 25 acres for $272,000. In many communities, this evolves into large watersheds. Houston, Texas Source Water Protection Program monitors over 600 miles serving 4 counties. Houston has a blend of 3 surface water plants and several wells that are 1,200 feet deep, spread out over 7,000 miles of pipeline. Houston's distribution system alone loses an average of 22.4 billion gallons of water per year to leaks, and Houston's average 15% water loss from broken pipes is enough to supply 383,000 residents with water for a year. Houston's budget often includes calculations such as $31 million to patch leaks, $54 million for water main replacement, and that $54 million addresses about 1% of the city's distribution main. Metering, pipe repair, and pipe replacement are obvious ways to identify and correct a utility's water loss. The first water meters in the U.S. were developed in 1857. In 1990, England and Wales urged 9 of their 24 water companies to also adopt metering in all the homes that they serve. Many developing countries still lack adequate water supply infrastructure, let alone metered water. In America, we have long considered water meters the cash register of the system. Tracking non-revenue water loss data is another key tool that meters assist with. For decades, U.S. utility managers have charted daily water pumped to their water towers and then at the end of the month deducted their metered water gallons sold to estimate water loss. By the mid-1980s, PLCs began to allow better communication between the treatment plant, storage tank, and the managers. Next came AMR, automatic meter reading systems, which assured more accurate revenue counting, but also quickly evolved into linking meters into utilities' SCADA control networks to provide real-time comparisons of treated water produced versus the metered billed data. Remote metering suddenly provided better evaluation of the distribution grid and theoretically quicker identification of where the lost water was flowing. There is no U.S. interstate piping system. Think of how the interstate highway conditions are generally better than state and local roads. Aging, undersized, and outdated piping is a key variable in the U.S. non-revenue water loss problem. The EPA estimates $200 billion must be spent on water system upgrades over the next 20 years. 29% of that will be spent on water loss control. Water loss management in the U.S. is complicated by the lack of a federally managed interstate distribution system. In fact, each city and rural water system is managed by a separate city council or water board. The Center for Disease Control estimates there's over 156,000 different public water systems in the United States. Each of those public water systems has its own annual budget, its own specifications, and its own political agendas and own record-keeping systems. Almost every road in the USA, whether it's paved or unpaved, has a water main running parallel to the roadway, either city or rural water. There are over 4.2 million miles of paved federal and state roads in the U.S. This map is just interstate and state highways and doesn't include paved county roads or our nation's 1.4 million miles of unpaved roads. In this example, we see the importance of replacing America's aging infrastructure. In this one city of 168,000 people, if the pipe, valves, and appurtenances were to all be replaced based on a useful life of 50 years, they would currently have 526 miles of pipe to replace. In 2020, at least 26 states in the U.S. were hit with tax revenue shortfalls. Many mayors froze their budgets after April of 2020 due to COVID, and spending cuts took place. AVK's territory managers work with the Water Technology Alliance to incorporate free training and assistance to utility managers across the U.S. AVK's training options are extensive and diverse. AVK webinars, AVK certified online training, AVK certified factory training, and tours. AVK designs products to have a minimum useful life of 50 years when correctly installed and used. AVK products provide maximum return on investment for the utility's dollar. Specify AVK and you no longer are faced with the old adage of price, quality, and service, choose two. Every dollar you spend on AVK provides maximum return on investment. AVK's proprietary rubber technology assures only the best ingredients and manufacturing processes are used. AVK products are highly resistant to corrosion, and AVK products for non-revenue water loss solutions are manufactured with quality, long life, and problem solving in mind. Examples are river, stream, and creek crossings that are critical failure points in water distribution systems. The force of the water can cause pipe breakage underwater that can go undetected for months. Ground shifting during seasons of freezing and thawing can also become troublesome near such crossings. An example was earlier mentioned with Tulsa having over 140 leaks in one day. Pipe deflection angles on the river or creek banks can be significant, and that also creates stress on the piping system. For river crossings, the AVK Series 66 fused to HDPE pipe is the best solution for a long-term leak-free system. Road bores under streets and highways are also natural installations for AVK Advanced products. As outdated and undersized piping and casing systems from older road bores are replaced, the AVK Series 66 is a key component for upgraded road crossings. Leak-free, fusible connections for gate valves and the roadway easement connected to HDPE water mains assure a joint-free system in the utility corridor. Whether above ground or below, the AVK gate valves with the Hymax grips provide a wide range connection for almost any type of pipe. This connection allows quick and easy adaptation from ductile to HDPE, ductile to PVC, or even IPS to DIPS transition. And a Hymax by flange option is also available. The stab fit design has two-stage sealing, using both mechanical and hydraulic sealing for a leak-free, restrained connection that prevents blow-offs of the valve or hydrant due to pressure surges or ground shifts. This unique sealing enables continuous dynamic deflection at the valve or the fire hydrant, substantially reducing potential future breaks where connected to the pipe. Severe soil conditions. All ferrous components of the valve that are exposed to internal or external corrosive mediums are coated with fusion-bonded epoxy in accordance to AWWA C550. After the valve or hydrant is assembled, the exterior is coated with a thick film with a dry film thickness between 50 to 120 mils thick. Here's an example for an ideal PUR-coated valve installation. It's a replacement of two 24-inch OS&Ys near a sea spray environment in Florida. AVK is able to provide a bid for a longer lasting, more durable PUR coating. We do take coatings very seriously, including fire hydrant coatings, because rusting bolts and decaying bodies create leak paths. The AVK, or the hydrant at the left, was replaced by the AVK test hydrant at the right. After 1 year, there was negligible corrosion in the highly corrosive sea spray environment. Main valve leakage in a fire hydrant due to rock or debris is common. AVK's fire hydrant main valve is so durable, and AVK's proprietary rubber has such good memory, it now has a 25-year warranty. Wet barrel hydrants are specified in warmer climates where the risk of freezing is minimal. When hit by a car, a typical wet barrel hydrant can lose an average of 8,000 gallons of water per minute, and that's non-revenue water. And before the cities can mobilize, shut the mains down, and repair the hydrant, it may take up to 40 minutes. That'll be about 320,000 gallons of water loss. AVK's answer is the FlowGuard 2. It will fit any manufacturer's wet barrel hydrant. With AVK's FlowGuard 2, if a wet barrel hydrant is knocked off in a traffic accident, the ball will rise to seal off the flow from the main, but it also allows a small jet of water to pass and reduce the water hammer and also indicate the line's been broken. With AVK's FlowGuard 2, when the hydrant is closed, the ball will settle and seal in a reverse direction. preventing backflow or cross-contamination problems. The brake flange is easily replaceable in the check valve to get the hydrant back into service quickly. Annual water main flushing is also very important. Unidirectional flushing can reduce non-revenue water loss by up to 40%. This is important because many utilities do not meter water when flushing. Flushing should involve a unidirectional program, and conventional flushing often involves no plan other than random opening and closing of fire hydrants. With a unidirectional flushing, again, you can reduce your water loss by up to 40%. Other things we're doing to address water loss and get you back in business quickly are the AVK Field Assist. It brings the operator and experts together to solve issues in the field. Whether it's a leaking valve in a treatment plant or a fire hydrant leaking due to obstructions at the base, AVK Field Assist gives you the quickest option to connect with engineers in real time. With AVK Field Assist, we share a live screen with you, and that's where you're located at physically. It allows us to engage with you and provide instructions in real time. This is great if you have staff who would prefer not to read instructions or the maintenance manual. It's like FaceTime, two-way video, but we use augmented reality so that we can actually have a layer of engagement between you and the expert. We can remotely mark and draw on your screen and assist during your site inspection and service. You simply download the Vuforia Chalk app. You then receive a code from the AVK expert. And if you have an issue in the field, such as a leaking hydrant, maybe an employee that's never worked on a hydrant before, or a check valve leaking that needs O-rings replaced and you've never done that before, the AVK Territory Manager will direct your staff to download the app. The Field Assist host will start the session and send you the code. You simply enter the code and join the session, and then the AVK Field Assist host or assists you to help resolve the issue and ends the call. AVK Field Assist gives utility operators the option of having water loss issues resolved quickly. This brings us to the end of the presentation on the non-revenue water loss. I'd like to mention you can always visit our website for more information on our products, take a virtual tour of our manufacturing facility, download data sheets, watch installation and maintenance videos, or view AVK brochures. We also have an online training program where you can take online training to learn more about our products, and it's free online, and we have over 50 courses on all subjects, ranging from how to calculate bury depth on a hydrant to how to change the signal on a post indicator valve. If you need any more additional information, feel free to contact me. My information's on the screen, or AVK Customer Service.